Hi. So in this video we're going to look at quantiles and how quantiles are defined, how we can work them out when we know the distribution function, and also how we can calculate them if we've just got some empirical data. So that's the idea of this little video. Okay, so what's a quantile? Quantile is a value where you sort of know what the probability is of being below it. So for instance, you might want to know the median, which is the 0.5 quantile, and that's the value where there's 50% chance or 0.5 chance of getting the random variable below that. Equally, that means there's 0.5 chance of being above it, so it's in the middle. Sometimes you also want to know high quantiles, like the 0.9 quantile, and that's a large value, and that means there's 0.9 chance of the random variable being below it. So 90% of the data, if you like, is below that value. So it gives you an idea of what a high value could be. A good example is the incubation time for COVID. The median incubation time, 0.5 quantile, is 5 days. So it means there's 0.5 chance of having incubation below 5 days. Also means there's a 0.5 chance of having your incubation time above 5 days. If you went up to, say, onto the 0.975 quantile, that's something more like 10 days. So there's if it's up at 10 days, there's 0.975 chance that the incubation time will be below 10 days, but that means there's 0.025 chance, 2.5% chance of having incubation just longer than 10 days. So that's an example of a high quantile. So that's the gist of it. How do we define it mathematically? Well, let's have a go. So the basic idea is P is your probability that you want to specify, and you want this probability. You want the probability that the random variable is less than or equal to this quantile, the xp, the pth quantile. So the probability that the random variable is less than or equal to this pth quantile has got to be equal to p. So that's the defining equation for a quantile. Sometimes quantiles are called percentiles. That's when p is expressed as a percent rather than as a fraction from 0 to 1. So the 90th percentile is the same as the 0.9 quantile. So where do we go from there? Well, the probability of random variables less than a certain thing, that is the cumulative distribution function. So we can write that as f of xp. Yeah. So if we know the cumulative, so f is the cumulative distribution function. So if we know the cumulative distribution, we got that. And we can find xp now by just inverting this equation. So that basically means that xp, the pth quantile, is the inverse of the cumulative distribution function of p. This inverse of the f is sometimes called the quantile function. So let's do a little example here. Small example. Let's do the exponential distribution. Suppose the random variable is exponentially distributed. That basically means that f of x is 1 minus e to the minus theta x. So this means the derivative of this, the probability density function, is exponentially decaying. So to find the quantile, what we do is we use this little equation here. So that means that f of xp is 1 minus e to the minus theta xp, and that has got to equal p. So we can then invert this equation here. So we then get that means that e to the minus theta xp is 1 minus p. That means that theta xp is minus log of 1 minus p, and that means that xp is just minus 1 over theta, the scale parameter of the distribution, log of 1 minus p. So if I give you the P, the 0.5 or the 0.9, whatever quantile the value I'd like, the probability I'd like, then put it into here, you can find yourself the quantile. So that's a theoretical quantile. So that's nice. If we know the distribution, we can do that. What can we do if we don't know the distribution? If we've just got some data, can we do it empirically? And we can. There's an empirical distribution function. So let's just see how we do that. We do this. So with a data set, let's take some data. Got x1, x2, got n values, and we can sort them. And we can sort them into the smallest value, let's call it x square brackets 1, the next biggest value, right up to the maximum value. Yeah. So this one at the bottom is the minimum, and this one at the top here over here is the max. So with any data set, set of data values, we can sort them into the smallest to the largest. And the position amongst here, this position of where these data values fall, is called the rank. So so this one is rank 1, the minimum value has got rank 1, the next biggest value is rank 2, and the maximum value has got rank n. Yeah? So let's do an example. So let's make some data. So let's say we've got 6, 2, 4, 3, 7, 9. Yeah. So let's sort it. And if we sort that, we get the smallest one in here is 2, the next smallest is 3, next smallest is 4, next smallest is 6, and then this 7 and 9. Yeah? So we sorted the data from the smallest to the biggest. Yeah? We can also look at the rank now. We've got them sorted. We can see which is the rank. So let's put rank here. So 2 is down in the smallest position, so it has rank 1. 9 is up at the biggest value, so that's 1, 2, 3, 4, 5. N is 6, so this is up at rank 6. 3 is in the next position, so that's rank 2. 4 is in the third position. 6 is in the fourth position, and 7 is in the fifth position. So the rank gives you an idea of where the data is, so we know where these data values are in here. And the rank is very nice because it tells you how many what fraction of data is below that value. So if we're in the middle, so we take halfway through, 6 is about 3, so number 4, half the values are sort of below 4 and half the values are above it. So this is like the 0.5 quantile. So we can use these sorted values. These sorted values are called order statistics. We can use those. They're basically quantiles. So to put it mathematically, the probability of x being less than the order statistic with rank r is going to be roughly the fraction of data below that, which is r over n. So this is an empirical. What's called an empirical probability. So we've worked that out just from the rank of the data, the rank divided by n, and the chance of getting something less than this value is basically the rank divided by n. So our order statistics are basically quantiles with known p's. And if you wanted a different quantile, all you can do is just basically interpolate between these order statistics. Yeah. So you can take linear combinations of nearby ones to try and find the quantile you want. And that's how the function in R does it. So if you do quantile some data x, a vector of data x with say 0.5, you want 0.51, it will go through, it'll sort the data into order, find the order statistics, and then it will interpolate them to find you the empirical quantiles. And that's how you do it empirically with the data. So this was the empirical way, and this was the theoretical way. So still there. Thank you.